Oh, okay. We're good. So I installed Wine, the Windows emulator, and I'm running. If you go to my site and you type files, you can download SimStructure setup. That's a Windows application, and you can. I wrote this in 2001, 2001. So I want to check something. This is a big test. So there's a bouncy ball. Where is it? There we go. Okay. So I want to test this in SimStructure.
Check out how high these different balls bounce. The basketball, the super bouncy ball, and the golf ball. Now I'm going to try the golf ball on top of the bouncy ball on top of the basketball. And then I'm going to explain how it's related to a supernova. Can you see that? Probably not.
Okay, so let's make some bouncy balls. Okay, we're going to reset. So I think, is there a snap? Oh no, anyway, that's good. Oh no, what if it doesn't work? Okay, let's see. I think it failed. You can set the hardness. I don't think that's gonna matter. Oh, I know what. Let's set the simulation to higher. Dang, I could swear there was a that I did that. I could swear I did that as an example. I guess not. So this is plotting potential and kinetic energy and total energy, and it does a pretty good job of conserving energy, which is a sign that the simulation is good. But it didn't do the bounce correctly. That sucks. So I made a so this is for designing. I wrote this program so that I can design control systems and not have to build expensive motors and stuff. So you can pick this up. This used to be pretty impressive. I wrote this in 2000, 2001, but now they have Grand Theft Auto and it has a compiler. Actually, it's an interpreter. So for the control system, you have gains and I just monkeyed together a control system, PID controllers and stuff. Anyway, let's do a rocket. There's a reset. Why isn't it, new? No? Right. I could swear there was a, oh well, let's do a rocket. So you put a thruster, then okay, so the reason SimStructure is a good program is because, boy, it's been a while. Particle 2. You can say thruster 1 thrust equals thruster 1 saturation thrust times P2Y. How about 30 minus P2Y? These are 5 units. Now, okay, so this is what's called a, well, it's oscillating. Now let's add a derivative. Plus, let's see, 0.001 particle 1 derivative in the y. So we're adding particle 1. We probably want to subtract 1,000th Okay, let's do more than it's 100th. Okay, 1/10. I don't know if it's making a difference. We should say P2, by the way. Okay, that makes a difference. Okay, so now we're it's too much gain. So 0. Okay, so what we should do is uh-oh. Oh, that was dumb. Okay. So we have a proportional and a derivative. I'm going to decrease the gain on the You might ask why we have a steady state error. That's because we need to make an integrator. I think you can say double desired. So this was my first, it was an interpreter. It's not a compiler. PID stands for proportional integral differential. So we're going to make, let's see if I can remember. Let's see. So error is equal to desired y minus p2. Okay. Now we say integrator. Say I. Now that will this will integrate the error. now it should drive the error to zero steady state error. Oh, we overshot. Okay, it's going to take a long time. So now we want to let's increase the differential. I don't think we want to overshoot so much. Well, wait a minute. I think we want to. The other answer. Let's too much derivative. Woo! Oh no. Too much integrator. And we can plot the if you say signal, I do believe this will. Do we have to say plot? No. Okay, then we have to say plot. I think we say plot. Yes. Okay. Yes. It's been 3 or 4 years since I used this. Damn it. Actually, I have the source code. I wrote it. Okay, anyway. Oh, we can look at a different example. So let's file, save as. What the heck? Rocket. Now let's do file open. I think the one of these has a one of these has a plot. Oh, this does. Okay. So we go to command window. Whoops. Oh, yeah, command window. What? That had a plot. It's not quite working right. It's got bugs. It didn't have. Maybe that's because I had the window open. So watch this. 1 to release the anchor. 2, 3. Anyway, oh, there we go. Okay, so how do we, oops. There we go. You say signal, you assign, and then you just say plot. Okay. Now we open. Rocket. Plot S. Okay. So now we can see the error. We overshoot. Okay, so if you overshoot, you want less gain or more derivative. The derivative subtracts. Okay, that's really bad. I think we have too much integrator. Uh-oh, we crashed. Oh well. Oh well. That was SimStructure. That's what I did before TempleOS. That's what I did before TempleOS. So I put the engine from SimStructure into TempleOS. For example, strut. So strut is These are masses and springs. The connector is a member that will break, or it'll break when you press that key. Thruster 2, thruster 1, thruster 3. Okay, so this is in TempleOS. Now I can press 1, I can press 2, press 3. So the code is all there. Let's talk to God. Do you remember this program? This program reads the 3 gigahertz timestamp count and then prints a random word. Prints a word based on the timer. Grouse. So we got some geniuses, do we? So I want to how do you make a nude? Oops. Uh-oh. I'm not much of a Linux expert. What the Uh-oh, now I fucked. Okay, so CD desktop. that's pretty up. Okay. I hit that bug before. Why? Wait a minute. Email. Move. What? Why isn't it? Any idea why it's not listed? Oh, how about that? Oh, it's in CAD desktop. Okay, everything's clear. I have to copy. Now I have to list. And do you think I have to say wine? I just installed wine for the first time. Will it let me say wine? What did it do? It's clicking. There's oh, it's flashed really fast. Okay. So CD. Hey, maybe I can click on it. How do you get it to show hidden directories in this? Oh, I didn't put it in. You think it needs quotes? Probably. Now that I think about it. Oh, what? I think that's what I did the last time. Oh, okay. So, just to be clear, oops. We probably need quotes. Is that how it works? Okay, how about no quotes? I don't know. I'll work on it some other time. Okay. Any Linux experts? So this is you can control the angle of the thruster. T1 angle equals now there's a oh, how about P2x minus P1 dot x. So now we're going to perturb. Okay, it went the wrong way. P1x minus P2x. Let's make it more gentle. Oh, there's a heading. Okay, we'll do that. So now this is rocket science. Okay, so there's a spin. Okay, first of all, there's a heading. I think you have to say pi times. They're called bonds and particles instead of masses and springs. Don't ask. I didn't like the word member. I was thinking of members, and so bonds and particles. You can put electrostatic forces. think we want unwrap. I call it unwrap. That was a mistake. Instead of wrap. Wait, let's just convert it. Did I use lowercase? Maybe I got it. Yeah, I used lowercase. Okay. Okay. Okay, it doesn't appear to be doing anything. It seems to be 0. Bond heading. I think you want to say let's put it on the screen. I don't remember how. Okay. Oh. Okay, it's degrees. It's degrees. So we say I think there's an error. How about okay, let's oops. Oh. I think, how do you, shit. Let's put this. This is interesting. Step function. So it's a hovercraft. Okay. What was the error? Warning, text statement, time identifier. Okay, oh! So, you can, okay. So, you might ask, what are we doing? This is not C if it's is this a function or what is this? What this is statements that get integrated, that get executed every time it, I don't know, what is it? Statements that get executed every time it calls the integrator callback. Anyway, if you can make things execute on a schedule like every 10th of a second. These @ signs make it execute when it plots it on the screen. So the A variable. Oh, okay. That's a one-time. It's coming back to me. I wrote this a long time ago. Okay, so okay, it's the wrong sign. Okay, now we have a controller. So there's a spin, which is the derivative of the heading. Okay, notice how now it's we have a controller. Okay, so you can make it go to an XY. Anyway, I've showed what I wanted to show. Okay, so now I want to make a Linux. What is this? SimStructure. So I'm just checking if I have the standard. Yeah. So in my bin, oh, we have to say wine. Uh-oh. So uh-oh. No striker. Hey, it works. Okay. Now, okay, now, oh, we have to say, okay. Now, copy, go to desktop, delete that, paste, and now, hopefully, let's go to desktop, properties, what do these look like? Oh, the other answer. Okay, so now we go to okay, this is okay, now copy. desktop, delete, paste. Damn it. Dad. Save. What did that do? Oh, okay. Now I know the problem. Okay. There we go. Okay, just there. Okay. Now, oh well. How about enough for